Hello and welcome to episode 18 of How to Code Games in BBC Basic. In this video we're going to be looking at missile mechanics, which is essentially how you can move a missile across the screen. So missile mechanics are obviously a very important part of an arcade game, especially one like Cosmic Invaders, because it's really important to be able to control where on the screen a missile appears and to ensure that the missile continues to effectively have a life of its own even after the user has pressed the fire key. And the way that that's done is through the combination of a procedure that initiates the firing of the missile and then another procedure which governs where the missile is on the screen at any given point in time. So you'll recall from the last video when we looked at proc key test that one of the key tests that is checked for is the shift key, which is represented by the in key -1 here. So if the user presses the shift key and there's not currently a missile on the screen, which is an important check obviously because this game only supports one missile at a time, um, and that's what that variable is. The missile percentage is just a true or false variable, which represents whether there is a missile on the screen, in which case it's true, and if there isn't, it's false, and in which case here, if the user has pressed the shift key, we can go to procfire. So we'll go to procfire. It's a fairly simple procedure. As you can see, it doesn't have a huge amount going on, but it's effectively a sort of setup procedure. So the first thing it does is it plays a sound effect of the firing of the missile. Obviously, we looked at sound and envelope in a previous video, but that's really just making a sound effect, a sort of whoop sound, which is the sound of you firing your missile. The next thing it does is it sets the all-important missile percentage variable to true, which is obviously significant because having now set it to true, it means that if the user presses the shift key again, it's not going to launch another missile on the next iteration of the game loop. And then finally, what it needs to do is it needs to set up our X and Y coordinates for the missile at the point at which it's fired. Now, the X coordinate, bearing in mind that obviously we already have a B percentage variable which tells us the position of where our base is on the screen, so the thing that's launching the missile. What it does here is it sets the value of the X percentage coordinate for the missile to B percentage +2. The +2 is important because our missile base is actually made up of multiple sixels, and what we want to do is actually show the missile coming out of the middle of the base. We don't want it coming out of the far left corner or the far right hand corner of the missile base. So we just add 2 to govern that, and then we set the Y coordinate of the missile to a value of 22. And that's just hard coded. 22 represents one space directly above our missile launcher at the bottom of the screen. So if you'll recall from previous videos, the way that mode 7 is laid out on screen, in fact we can show this in our bbem here. So if I do a print tab command of 0, 0, and I put in a question mark here, what that will actually do is it changes the right hand bracket here to a question mark, and I could change it to something else if I wanted to. I could put something else. I could even write the word hello starting from 0, 0, and it'll just overwrite what's already there on the screen. So that's if you think about it, that's print 0, 0 or print tab 0, 0 will start you at the sort of top left hand corner of the screen. 0, 23 or 22, let's say, which is what we would have here. If I put something down there, so I'll just put the character of X, you can see that it comes down here. And the other important thing to remember about good old PRINTTAB is that it doesn't just print something on the screen, it also resets the positioning of the print cursor itself. Now, if I don't put a semicolon after it, it'll go on to the next line having printed what it prints. But if I were to do, let's do something further up the screen, let's do 5, I don't know, 13. So we'll do something sort of towards the middle of the screen. If I put XYZ, then again, you can see that it prints it, but then it moves our cursor directly to the next line and setting the X coordinate back to 0. Now, if I repeat this line here and say, all right, now I want to do, let's do 7, 7, and I'm going to just print, I don't know, the letter C with a semicolon. It prints it, and then it actually leaves the print cursor in the next position along from where it's printed that C. So that's just a reminder, quick refresher on the syntax of PRINTTAB and XY coordinates. So with this, as you can see, with it being a b percentage plus 2, so you can imagine that the base is somewhere along this x coordinate here, but you can't move your base up and down, so the base can only ever have an x coordinate, which is why we can just borrow it to start the position of our missile. The y coordinate 22 is down here, as we saw. So that's all that procfire is doing. It's just setting up the initial x and y coordinates for the missile. The real guts of the operation is handled by procmove missile, and indeed procmove missile will be called every time the game loop comes around, provided that missile percentage has a value of true. So if missile percentage is true, this procmove missile will be called. So not just after having called procfire, but every time the game loop iterates and the value of missile percentage is true, which indicates that there's a missile in flight. So now we come to this procedure, move missile. So we'll ignore line 1570 because, to be frank with you, I don't really know why it's there. These variables don't actually have any role to play within the procedure itself, so I'm not sure whether that was a mistake or whether that was left in for something that wasn't subsequently programmed, but we'll just skip over that line. So the first thing that this procedure will do is it will set the print tab for the position of the missile, bearing in mind, of course, that the first time this runs, these values will have been set by procfire, but on any subsequent iteration of move missile, they might have changed. I say they might have changed. The x percentage coordinate for the missile will never change because a missile can only go in a vertical position. It can't ever sort of move from left to right. Once you've fired it, it'll just maintain the same x position throughout. But this value of y for the missile coordinate will of course change each time this procedure is called, and we'll see why in a minute. But first of all, as I say, all we're doing here is we're setting the position of the print tab, but note we're not actually printing anything at this point, hence the semicolon. Now the next line, we're going to explore the details of this in a future video, but this is really the collision detection line. So what this is saying is if the result of this function returns a value of something other than 32, so the value that comes back isn't 32, 32 is the ASCII value of space. So effectively what we're saying here is if this function tells us that at that print tab position, which bearing in mind is the print tab position where we want to print the missile on the screen in this particular iteration of move missile, if there's something already there, so effectively there's something already on the screen in the position where we're about to put the missile, then we want to call proc hit, which will govern all of the collision detection logic. As I say, we will look at that in a future video, but suffice it to say, if that is the case, so if the position in which we want to now print the missile has already got something in it, we need to get out of this procedure straight away because we don't want to start fiddling around with printing missiles on screen. There's already something there, so we need to call proc hit to deal with the consequences of that and then jump out of the procedure with this goto command. So we'll assume that there isn't anything in the position where we want to print the missile. So the first thing that we need to do is, this looks a little bit peculiar, right? We've set the print tab to the x, y position, and then the next thing we're doing is we're saying, well, now I want to add 1 to the y coordinate. Now, there is a sense to this. This line is setting our print tab in order to then say, well, given that we're about to print in this position, please tell me whether there's something already there. Right, so that's why we do it. Now, we're only going to get to line 1600 if the result of this logic here didn't result in us needing to go into proc hit and jumping out of the procedure. So we can assume, therefore, if we get to this line, it means at that proposed position for the missile, there isn't anything. So the next thing to do is before we print something in the position that we want to, i.e. before we put the missile at its next position on the screen, we need to make sure we cover our tracks. Because what we're trying to do here is we're trying to simulate a missile moving up the screen. But to do that, we have to employ a rather clever trick, and you'll see this in lots and lots of basic-based games where you're effectively trying to simulate movement on a screen. And we're going to look at the details of it in this little program here. So I've written a short program. It's a very, very badly written program because, of course, I've effectively repeated the same logic multiple times. You would never write a program like this in practice because you would use a loop to do it. But I am deliberately doing it as a demonstration, so please don't criticize my programming skills. This is just here for the purposes of illustration. So what we will do is we'll run this just so you can see what it does. And lo and behold, we have the simulation of a missile running up the screen. Just run it again just to make sure you saw that, so you can see it started down here and then it gradually moves its way up. Now it's all an illusion because what we're actually doing is we're just calling a series of print tabs with a short delay in between so that you can actually see the movement happening. We're just calling a series of print tabs, but each time we print, or rather I should say each time after we've printed a missile, we then print a space in the position where the missile was before we then print the missile one space above it. And that gives you the illusion of it moving up the screen. Now, if we didn't print these spaces, I will show you what that actually looks like. So if we just quickly look at this, this is the same program, but all I've done here is I've just stuck a rem in front of the print tabs that print the spaces. So if we run this program, this is what happens, which of course does not give you the illusion of a missile moving up the screen. It just kind of looks weird, like you're, I don't know, leaving missiles behind you, like some kind of weird missile self-generating thing. And it's not what you want, because the whole point is that you want the illusion of a missile actually moving rather than just printing missiles one on top of the other. So that is what the logic is of this procedure, is we're saying before I print my next missile in sequence, so as in before I move the missile, so to speak, one space up, I need to cover what was on the screen with a space. Because in BBC Basic and indeed in programming for the BBC Micro generally, once you've printed something on the screen, unless you issue a clear screen command, it'll just sit there. You can't move it. You can't physically say, I want to take the thing that's in that position and move it. But what you can do is you can, of course, overwrite it with something else. And that's actually what we were doing earlier when I did my PRINTTAB 0,0 command here. When I say this, or rather, sorry, if I should run hang on. It doesn't help that I'm not actually at the top of the screen anymore. Let's do a quick CLS. There we go. So as I say, when I was doing my 0,0 before, and I put, I don't know, put an H there, you see that's what's actually happening. That triangular bracket is, once it's there on the screen, you can't get rid of it unless you print something over the top of it. And of course, if the thing that you print over the top of it is a space, it makes it look like it's vanished. And that's effectively the logic of the move missile procedure. So as I say, just to recap, we set the print tab to where we want the missile to go. We check to see whether there's anything already in that position. And if there is, obviously we will go into the collision detection logic, but that's the subject of another video. And then having done that, the next thing we want to do is add 1 to the y coordinate, which if you remember your y coordinates, the lower the number, obviously the higher up the screen it is. So by sort of perverse logic, but the greater the number, the lower down the screen it is. So essentially we're saying, well, I want to put a space in the position where the missile was on the last iteration of the game loop. And then having done that, we say, right, now we can set our print tab back again. So essentially line 1620 is the same as line 1580. The only difference is that now we know we're safe to print the missile in that position because we've got into this element of the procedure. We would never get here if there was something already in that position because we would have jumped out of the procedure in line 1590. So we're now safe to print a new missile. The only check we need to do is make sure that the Y value is not a value of 1. Why do we do that? Well, technically speaking, the top of the screen is where the score is displayed, and we don't want the missile firing through the score display at the top because that just looks a little bit clumsy. So we say, well, provided the value of y is not 1, so as in provided it hasn't got to the top of the game space, of the game arena, then we print a missile in the position we want it to show up in. The last thing that the procedure needs to do, of course, is manage the value of y, the y coordinate of the missile, for the next time the game loop runs around. So first of all, it says, well, if we're still greater than a value of 1, which is to say we started at a value of 22, provided it's somewhere between 22 and 1, but not 1 itself, obviously, because that's already governed here. So provided it's somewhere between 22 and 2, then what we do is we say, right, reset the value, the y percentage of the missile, the y coordinate of the missile, to 1 less than what it currently is. And that sets us up nicely for the next time that procmove missile is called, because then obviously the print tab will set to 1 position above where we are currently. And then obviously if it's the case that this value is either 1 or 0. Technically, I don't think it can ever be 0. But basically, if the missile has got to the top of the screen, so it's actually 1, so a value of 1, then we go into the else part of the if statement and we set missile percentage to false. And all that does is allow the user to press the shift key again and launch another missile. So taken in combination, this procedure is doing quite a few important things. It doesn't just govern how to move the missile up the screen, it's also covering our tracks to make it look like the missile is moving, to simulate the idea of movement. And on top of that, it's also governing the values of the y coordinate of the missile, not just for the current iteration, but for the next iteration that will happen when the procedure is called again. And finally, it's governing the missile percentage variable so that if the missile has reached the top of the screen having not hit anything at all, then it sets that value to false and allows the user to be able to launch another missile should they press the shift key. So that, in a nutshell, is missile mechanics. And it's all, as I say, governed through the use of coordinates and a very clever use of the print tab command with different Y positionings to give the illusion of movement. That's effectively how it works. So I hope you've enjoyed that. We'll probably look at the actual collision detection logic in more detail in the next video to make sense of what this function is actually doing in practice, and also what then happens in the proc hit procedure should the program determine that actually the missile has hit something. Hope you've enjoyed that, and I hope you'll join me for the next video in the series. And until then, goodbye.